How many non-Polish speakers we have? Oh, I mean non-Polish. Please raise your hands if you don't speak Polish. You're welcome, Larry. Yeah. A bit about me. My name is Maciej Mensfeld. I'm a software engineer and software architect, however you call it. I just program stuff and think about what I do. I'm not only typing, so I guess it's something more than a programmer. I do a lot of open source, mostly, which is kind of nice because someone pays me for doing stuff I can give away for free, which is even better. You can find me on Twitter. I run a blog about programming and Kafka-related stuff. I work for Castle. Castle is a company that detects and takes care of mitigates of accounts for mobile and web applications. Really interesting stuff. We detect that you've got hacked, basically. And to give you a quick overview of what I deal with, it's around 100 million events per day, 20 million active users daily, 50 million active users overall, and 2.5 million failed login attempts daily. Please notify me if I speak too fast, if I should repeat something, if you have any questions, or if you want me to explain something better. I will be talking about Kafka mostly. Someone said that Kafka is future. I don't know, but I hope it is. I'm betting on it, and yeah. I will be talking about event-driven architecture a bit. What is Kafka? A bit of about Karafka, but I don't want to get into details, Ruby details too much. A bit about streams and the batches mindset and how software is being developed without it today, and how can we make it better. And I will show you some use cases of using Kafka and places where it can fit really nicely. And I hope that after the talk, you'll be able to see Kafka as a valuable component to your systems, and it's also as a part of infrastructure. Before we start, couple definitions, just to be clear. Yeah, I can read it, but yeah, event-driven architecture is just about broadcasting, sending messages, telling everyone what happened. Not what they're supposed to do, but what happened. So as I speak to you, I can, if I want you to do something, we can work in a way that I would tell you to do something, or I can just tell what I'm doing, and you can react based on it or not. And the second approach is exactly what event-driven architecture is about. For those that don't know, immutability is basically creating and freezing objects of all sort of kinds. If you have something, just don't change it, and long story short, it's immutable, which is really awesome because not having a state is better than having a state, because state can change, and I don't like it. Domain-driven design, it's just a way of designing applications in a way that will help you make them maintainable. Based on my experience, it's really easy to develop software. It's really hard to maintain it. And that's one of the reasons why programmers change jobs, because they develop software and then they're unable to maintain it. So they want to start again, so they quit and they find a new job. Because the market is really nice in Poland, and it's super easy to find the next greenfield project we can break again. In a different way, but still. Event sourcing, it's related to event-driven design. We just broadcast events, and we don't really care what other parts of other systems will do about it. We just tell what we do. And I won't go into details, but sagas or process managers are patterns and ways of building components in a system that will react upon multiple events happening in different time frames. And just to help you visualize a bit, a simple example, event-driven shopping cart. We just store what happened to it. If something was added, we store it. If something was removed, we store this information. What we don't do is that we never change what we already added to the system. So we don't, if a product is being removed, we don't remove the event. We add a new event that will remove the product from the shopping cart. And this allows us to do exactly what a typical shopping cart would do, to just store a quantity of items and details about them. But it gives us much more. It allows us to do data mining, to use AI engines and ask ourselves and allow business to ask questions that we wouldn't be able to answer, like what was going on with this shopping cart in between the moment the first product was added till the end of the whole shopping process, right? If we store only the current state, we remove 90 or 95% of information that can be really valuable to us. Because we can, based on how people shop online, in real shops as well, you can see patterns, and if you see patterns, you can use them for your own advantage. And by storing the current state, which is like the final moment before paying for the shopping cart, we lose this data. There are some benefits and drawbacks of event-driven architecture. All right, yeah, it works. If you think about it, this is how world works. I'm talking to you, and I hope you listen, but I don't explicitly require any of you to listen all the time. It's up to you to decide, right? So I'm just talking, and yeah, you can listen or not. But this is how we work. I send an email, and I don't wait up until I get a reply. I just do other things, and when I get a reply, I can act based on it. And the funny thing is that this is not how software is being modeled most of the time. Developers and architects, designers, they tend to focus on the current state, which is, they tend to just update things and maintain the current state. I don't have a way to call it differently, but they tend to forget about all the process that happened. Sometimes some people say that destination is less important than the travel, and you could adapt it and say that the whole process, all the events, quite often are more important than the final result. And by applying event-driven architecture, you get some really nice advantages. First of all, you don't have a point-to-point relationship in between your applications or components or modules, which means that they aren't dependent on each other. You can replace them, you can change technologies, you can change programming languages, probably to Perl 6. Yeah. Exactly. Or Ruby. But really, you can just build exactly the same part of the system in a different technology, put it side by side with already existing component and test it. See if it's faster, less, if it requires less CPU or anything you need to test out. You can do it in real time, even on production. If you have a system that is like read-only from the rest of the components perspective, you can easily test it on production. I shouldn't say that, but yeah, you can play with it on production. In the end, you get a bus architecture. So you have little tiny boxes that act independently. you don't have dependencies in between, as I said, in between components. And there is this microservice buzzword. People do microservices to get isolation. And quite often they use HTTP as a layer, which means that they don't have this isolation because in the end, you need to have HTTP server and client. And then if you change something on one side, you need to notify an update. The second one, probably you at some point you'll build up, I did that a couple of times, you'll build up API clients and you need to update them, you need to maintain them. If you add a new component to the system and it's written in different technology than the one you already have, you have to maintain, you have to develop and build up this API client for the new technology. You cannot just hook it up and figure things down the road. Event-driven design is great for performance, obviously because nothing can change. You don't have to update anything, so you just have to create events. It's great for scalability of the processing. It's great for scalability of the design and the business change. You can react much faster when you're able to add and remove components and you're quite sure that you won't break other parts of the system that aren't related to it. And the quality, overall quality is much better. The less you have to do to reach your goal, the better, and the less things you're able to break to reach the goal, the better. It's especially good for bigger organizations. People change jobs, and you get new programmers, you get new employees. And if you can get them really fast on board, then you save money. And you know, business is for, most of the businesses are for generating some money. And if you can save it and get people on board much faster, it's a win-win. Yeah, data is the new oil. We get new and new tools to process and analyze data. And if we remove the data we have today because we think of it as being irrelevant, we might not have a chance to work with it in a year or two, right? We may not use it now, but at some point we might ask ourselves some questions about the data, and then instead of answering like, oh, it would be nice to store it a couple of years ago, we can just take it out. Yeah, this is one of the downsides a bit, that things tend to happen asynchronously. But as I said, it's just a mindset. And you know, the real world is like this. So yeah, it's a bit harder to debug, for example, because you expected some events to happen, they didn't happen, and you need to check some things in between systems, but still, overall, it's better. And yeah, eventual consistency. Not always the best, and depending on the business, you might not be able to have eventual consistency. Your business might require something else. But for most of the non-mission critical systems, yeah, eventual consistency is the best consistency. And the biggest downside for me is that there is no update to event-driven architecture. So if you did something wrong, you need to fix it by creating new events and fixing it with events. There are no updates, right? So if you want to update something, you need to build up events that will change the current state. But the whole history is still there. And it can be a bit of over-engineering, to be honest. For a simple MVP, for really small business ideas, don't do it. It takes a lot of time to think about architecture and stuff. And if you have this great idea and if you want to validate in 2 weeks, don't even try to do it. Just go with create, read, update, delete system. And you'll probably be really sad if it works, because it's much harder to add event-driven approach to already existing typical systems. But at least you were able to prove your business idea, or you were able to spend only 2 weeks on validating it, not a couple of months or years building something that is like state-of-the-art engineering, but no one will use it. So what is the point? And yeah, a great tool for event-driven architecture is Apache Kafka. How many of you heard about Apache Kafka? Please raise your hands. So what are you doing here? No, just kidding. For those that don't know, it's a distributed streaming platform, or a distributed messaging system, or a distributed log storage. It has many names depending on your use case. Our use case is for storing events. It is really well designed, written in Java and Scala. It allows a single cluster to act as a data backbone for really big organizations. It can be expanded without downtimes, which is a huge benefit, because you can just migrate in between, for example, I don't know, AWS and Azure without any downtimes. You can reorganize your clusters and stuff like that, and everything will work without, major problems. You'll probably see some error notifications or something if you plug out components, but still it will solve things out. One of the biggest advantages, and comparing to typical queue systems like ZeroMQ or RabbitMQ, RabbitMQ provides broadcasting now, but it's much harder to do it, is that it provides broadcasting to many applications, which means that it acts exactly as I act for you. So I'm a Kafka, you just listen, you consume, so you're consumers, right? I send a single message to a system, and it gets delivered to all of you. And a couple weeks ago, someone said that Slack is a Kafka for people, because basically this is what happens on Slack. You send a message, and people will read it or not. But it gets broadcasted. And yeah, it allows to build event-driven systems. Everyone uses it. Everyone with some scale. Because it's good. The way it works is really simple. You can read from it, and you can send messages to it. That's all to say. You can do this in many ways. You can just hook up a connector from your database, and all the changes that happen to your database will be just sent to Kafka. You can stream messages to it. You can send messages to it, whatever you need. And the same with listening. Internally, Kafka is built based on a topic concept. Think of topic as a single queue. And within a topic, you will have partitions. And when you send a message, it will go to a partition. If you don't, you can decide to which partition will it go. I'll get back to it later. But by default, it will be just assigned to a random one. So if you're not doing some more advanced stuff, it will load balance automatically. When you start reading from it, you read from it based on consumer groups. And Kafka makes sure that a single message is being delivered to a single consumer from within a consumer group. And it is great because you can have more consumers in a consumer group than, for example, partitions in a topic. And if any of them dies, a different one will take over and process the stuff that should be processed, right? So you can just have a cluster, kill 20% of it or even more, and then it will continue to work. Really, really simple concept. Yeah, scaling. The more partitions you have, the more you can process. The downside, one of the requirements is that partition must fit to a single server, but it's a matter of storage. Kafka guarantees order within a partition of a topic. So if you're like event-based and time-based sensitive, you need to make sure that related events are being sent to the same partition, because otherwise you can end up in a point where you have events that happened later being delivered before other events. You can sort it out in memory later on if you want, but why would you, right? And there is a concept called partition keys that allows you to tell Kafka that all the messages, all the events with this partition key need to go to a single partition. You don't have to pick a partition on your own, but when you provide, for example, a string or an ID, all the messages or the events with the same ID will go to the same partition. Load balancing is great because you can just add more processing units and it will solve things out on its own. The same with fault tolerance. You can just kill, as I said, you can kill a lot of processes. It will still work. We used to migrate one system from bare metal infrastructure to AWS without downtime. So we would just spin up a process in AWS and kill one on the bare metal server, and it would allow us to transition without any downtimes in the infrastructure. It does not happen often, but it happens from time to time, and it's good to have it's good to be able to do that. You can rewind and replay, which means that if for any reason your business logic was bad and it shouldn't work the way it did, you can just get back to the last deploy moment and replay all the events, reprocess them again, and start from a clean slate. If you'd have a typical current state system, you wouldn't be able. You would either have to use some logs or a different approach to fix the data because you would not have the intermediate steps. With this, you can just tell Kafka, hey, give me last 2 days of events, and I'll do something with it. Really nice. Obviously, there's a lot of data, and sometimes you don't need all of it. And Kafka provides you a way to compact a log, which means that you can store only the most, after a while, you can store the last event with a given key or something. And it is really good when you deal with a lot of data that it's not as important. On the other hand, you should store it, but sometimes it's just a lot of data. Really short. How it works with Ruby. You don't have to be a Ruby programmer. You don't have to use it. It will work with any programming language that has Kafka drivers. Perl 6 has Kafka drivers, so you can use Perl. Probably the easiest way is with Kafka is to start with Java, because the client for Kafka for Java is provided by Apache Foundation itself, so it's always the most up-to-date. For Ruby, we have Karafka, thing that I built a long time ago, and I maintain. It was built because using a raw Kafka driver for Ruby was just pain in the ass. It was designed to make developers happy, so they can just plug it in and use it without understanding all the concepts behind it and having to wonder how it works, reading a lot of documentation. It's just plug and play. It was also developed so I could just build things faster, process faster, and handle a lot of events from different topic sources and so on. And one of the next reasons was that not all programmers are like low-level programmers. They don't want to play with threads. They don't want to understand signals and how to care of them. They don't want to understand load balancing or other things like failovers. They just want to plug a library and use it and hope that someone smarter figured things out. Not always happens, but yeah, I think we did a pretty good job with this one. So often people ask me, hey, we have HTTP, we could just use it and use REST or something HTTP based to transport the data. Yeah, but it's not broadcasting, right? So if you want to notify 20 apps, you need to ping them explicitly one after another, as long as you don't have anything fancy in between. Yeah, we often need to trigger multiple actions based on a single event, and the same happens. And we would have to maintain internal API clients, which sucks because it's programming. And if you can solve a problem without programming, it's better than solving a problem with programming. Yeah, I've been talking about it already, that you can just replay stuff and so on. And it is about messaging. And real life is asynchronous, and our apps should be like that. And you can do a lot with it. People say they're really slow. Most of the time, programmers are slow, not the language. I will give you the performance of 50K messages per second and try to do something with it. And if you are able to do something with it from a single process, then okay, then probably the language is slow. But most of the time, it's not the framework code nor the language itself. It's what we do with it that makes it slow. Obviously, the message size is a factor. So if you send big messages, even like parsing process will take a lot of time. And it really depends on what you do. You have this base performance and deal with it. It takes less than a millisecond to send a message with acknowledgement level set to, I think it's 1, it's a mistake. Basically, in Kafka, you have acknowledgement levels. You can make the whole cluster acknowledge that it got the message, or you can just make one node acknowledge the message. It depends on how important the event or the message is for you. If you generate like a lot of messages, then probably you need more performance than safety, you should go with the second one. On the other hand, you can use like asynchronous producers that will buffer stuff for half a second or a second and flush them in batches. Then it's really, really fast, and it takes even less time to deliver a lot of messages. And what I find really interesting is that when you take Kafka, people tend to apply the same approach for programming like they used to in the HTTP-based world. They tend to produce objects, and they tend to work with entities, one after another. And sometimes companies mail me and ask, hey, you're the maintainer. Do you think it's a good technology? And are you just maintaining it because you can go to conferences and stuff? And I'm like, I don't know. Show me the code. Because if your code is not ready, if your code is a typical code from a typical web system or whatever, and it's unable to use benefits of Kafka, then there is no point. You first need to spend half a year on redesigning some of the components so you can take advantage of it. Obviously, you can just put it in and start sending events, and at some point, some of your domains will clarify based on this, and then you can start slowly migrating. But you cannot think of Kafka as a plug-and-play solution that will just allow you to process 10 times more requests or whatever just by plugging it in. I'll give you a simple example of how it works. I used to help a company with events, with webhooks. So internally, the system would generate some events, and based on those events, we'd have to notify our customers with HTTP API. So they would be pinged when something happens. And it's a really simple thing to do when you ask a junior programmer or like a middle developer. What he will do is he will just take the events, use HTTP, and based on a single event, he'll send a single HTTP request to a client, which is really simple, right? Just like ping pong, we just send events. The problem emerges when you have more events and you send them to the client and you send them one by one. And client can be overloaded because he didn't expect that. He can have a really small infrastructure because he was used to having a single event per second, for example. Then you send him 100 times more. So the client can have downtimes. There are even socket limitations on Linux. There can be a network problem. You need to handle retries. Well, you always need to handle retries. But if you send 1,000 HTTP requests per second, and your customer server is being deployed and it takes 30 seconds, then you can calculate how many retries you need to handle. And it costs you money, right? Because you probably, if you're not using, you will be using at some point something like AWS. So you pay as you use. So the more you use, the more you pay. So failures on your customer's side costs you money. And this can be changed by changing the way you think about data. You can send a single event because it needs to be fast. By fast, I mean it needs to react upon an event, let's say, to 2 seconds or 5 seconds, right? Because there's like overhead of HTTP and stuff in the middle. But 1 up to 5 seconds, it's still OK. So when there's a single event, you'll just send it right away. But it would be nice if the increased number of events wouldn't cost you more in terms of HTTP requests. Why would it? If it wouldn't, it would auto-scale, right? Let's say we want to send 1,000 events in one request. We could do this. Then we, instead of 1,000 requests, HTTP requests, we just make one but bigger. Then it's easier to retry, and it's easier to provide some failovers and so on. And you can do this. You can just use Kafka, for example. You can just generate events, have a notification app that will just gather all the events. Kafka sends batches of messages. When you have a high traffic, you'll get more than one message in a batch. So you can just take this whole batch and send it in one request. It's way less work. But it requires a mindset. It also requires a mindset from your customer, because usually you don't start with Kafka. You have a typical system like that, right? You have a system, it works. But if at this point you make a slight change to the structure of JSON that you're sending to the client, which means that instead of sending a single JSON object, you will just wrap it with an array. This tells programmers on the other side that, OK, we're receiving array, so we probably should have something like a loop here. And you will still, for most of the time, you'll still be sending a single event. But it gives you the freedom of being able to send more. Because if you have customers, especially bigger customers, you'll have to think about them. And you won't be able to just change your JSON format. You'll be forced to support your own work for a longer period of time, at least until you just quit and change the job. But by telling them, hey guys, just expect batches. It's one for now, but please provide a loop. You can easily migrate to something like this without notifying the customer, right? As long as they just don't pick the first element from the array and ignore the rest of it, but it's on their side now. It's also much easier to provide alternative notification engines. Sending webhooks is one of them. If you need to build a Slack integration, nothing hard there. Just build the next app. Copy this one, and instead of sending to your customer endpoint, just send it to Slack API. You need push notifications. Do exactly the same. Just build a new app that will react upon the same event, and it will just send push notification to a phone. There are some bigger use cases. I have two, one in my mind and one here. Before I go to this one, I used to work with I used to develop a system. I took it over from a company that, oh, never mind. It was a really simple system. It was collecting mobile phone data. If you would go to a shopping gallery and if you would have this application, it would track you. Even if you would say no, we would track you. So, we could just calculate your position in real time, send you some cool offers. Oh, you're near this shop, let's give you 20% discount, blah, 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 right? There are two really interesting things. It would work from 8 to 8. The hours of gallery is open. The traffic would be like 0, 8, 8, 0. So it was obvious that it should auto-scale. It's not worth having the infrastructure 24/7 when we have galleries in Europe open from 8 or 7 to 8 or something. Cinemas work a bit longer, but it's not a problem. The problem is the whole gallery. The second thing is that we shouldn't care about events that are older than, let's say, 10 seconds, right? Or 20 seconds, because the customer is already somewhere else. If he's walking like I am here, in 10 seconds he will be somewhere else. So delays happen, even on the mobile side, right? The phone is not always online. So what we did, we had a Kafka cluster that would just throw events. The mobile phone would send HTTP requests. It would batch some data, obviously, each 2 or 5 seconds, and more if it was offline, because we would use the history for analytics. But we would have independent parts of the system, one responsible for real-time reactions, and it would just ignore all the old events. So if it would get events that are older than 5 seconds, it would just ignore all of them. It was blazing fast, because you don't do selects from the database from every second or something. You get those events, and even if they're older, you just don't care. It's a loop. You just ignore. What is really interesting in Kafka is that you can ignore messages based on the timestamp without unparsing the message, which is something like unusual, because if you get a HTTP request, you have headers and body, and you need to unparse it. Kafka provides some mechanisms, so you can get the timestamp when the message was created, and if it was old enough, you would just ignore it. So no parsing, no CPU, nothing. And then you can process a lot of data. And we would have a different part of the system that would do non-real-time analytics, like sending some email offers and so on. It wasn't that important to do it in real life, in real time. And it would use the same data, but just in a different way. And it works great, and it scales. A different example, it is a small platform for code analysis and automated code review, and it handles a lot of data. Like, it just reads code and checks who did some bad stuff, who did good stuff, things like that for Ruby. And it is designed around Kafka, basically. So each of the components maintains its own database. They're small, they can be scaled independently, they can be taken down, replaced, and you don't have to worry about other components. If you have a bug, it is isolated. But if you have part of the system that is scheduling something, obviously if you take it down, events won't happen, and then other system might stop working for the time being, but once this is online, it will just catch up. We just sent every single information that was useful to Kafka, and the good thing is that the applications don't have to care about the source of knowledge. So if you replace one application with another, it works. And we used to have exactly the same app working for part of the system in Ruby, and one working for the other parts of the system, JRuby or something else. They could do the same work, which means that we could validate how they work by comparing the results from one to another. It's a black box. So you give some events, you expect something back. This is really good for testing that two components that you want to replace work exactly like the new ones. There are no downtimes. Things get buffered in Kafka. You go online, it catch up. If you're interested, you can read more here. Kafka is getting bigger and bigger. It allows you to materialize views, which means that you can automatically have the current state alongside all the events. So if you need to do like typical SQL queries and stuff, it allows you to do that. There is something like case streams, which allows you to build up streams based on other streams, which is super interesting because then you can deploy it. It works like similar to AWS Lambda. So you can just deploy functions and it will transform streams. You can think of applications as components for a bigger pipeline, similar like you work with Bash. You just get a command, pipe it to the next one, pipe it to the next one. You can start thinking in an asynchronous way, and it helps. I have some tutorials for playing with it on my blog, playing with Kafka and Karafka, how to set it up, how to build simple systems, and how to get this feeling of how it works. And yeah, feel free to go on GitHub, check the sources, find errors, please submit pull requests, fix stuff, and so on. Just for the record, one of the biggest companies that is using this is called Shopify. It's a US-based, or Canada-based company that provides online shops that you can just customize and stuff, and they do a lot of things, and they're really happy.